Hello everyone, my name is Brant Kudrowski and I'd like to welcome you to Chem 234 Organic Chemistry Lab in fall semester 2020 at the University of Wisconsin Oshkosh. In this video, I'm going to start a basic overview of the course. This is the first of several introductory videos that are going to cover course policies, course format, course operation. Then there are other videos that'll follow after that that are going to cover content like experimental details, pre-lab readings, resources, those sorts of things. So all of this is going to be on the course Canvas site. So you should log into Canvas and take a look at the resources and materials that are listed for you there. And I just want to say welcome and hope you have a great semester. Looking forward to meeting you. Before we start talking about Organic Chemistry Lab, I should tell you a little bit about what organic chemistry is. It is the study of the structure and behavior of carbon-based molecules. So you might wonder, why carbon? It's a big periodic table. Well, carbon is a great building block for molecules. It forms 4 strong bonds with itself and many other atoms. Carbon can also adopt 3 different shapes. That adds to its versatility. And that leads to countless different possible combinations for molecules that can be made by connecting carbon and other atoms in the periodic table. This in turn leads to an incredible potential for molecular diversity, and the natural world contains millions of organic carbon-based molecules with unique structures, shapes, and properties. And in this course, we are going to get an introduction to this type of chemistry and start to learn about these molecules. They are literally everywhere in the world when you start knowing where to look for them. They're present in the foods we eat. They're present in the fuels we use to power our vehicles and heat our homes. They're in the plastics that we use for packaging and products that we use every day. They're in fabrics and clothes that we wear. They're in the drugs that we use to keep ourselves healthy. They're in dyes and pigments that make our world more colorful, and flavors and fragrances that make the world more interesting. This is just a basic general introduction and not at all a comprehensive list. The world is full of organic molecules and they are interesting. And in this lab course, we are going to get started learning about some of the properties of these molecules and some of the techniques we can use to study them. This slide will provide an introduction to Chem 234 Organic Chemistry 1 Lab. The course, Organic Chemistry 1, is a 1-credit class that's closely related to Chem 235. That's Organic Chemistry 1 Lecture, which is a 3-credit class. The 2 courses cover very similar content, but from different perspectives. The lecture is more focused on theory, while the lab is more focused on the hands-on aspects of chemistry. However, the 2, although they're related, are separate courses. Each one has its own syllabus, course policies, and grading scheme. This is different from general chemistry, where the lab and the lecture were integrated into one course, and you got one grade for both. In organic chemistry, the lecture and lab have separate grades. Prerequisites for the lab course are completion of Chem 106, that's General Chemistry 2, with a grade of C or better, concurrent enrollment in Chem 235, Organic Chemistry 1 Lecture, or previous completion of Chem 235 with a grade of C or better. When you take Chem 234 and 235 together, as most students do, you won't be able to drop one course component without also dropping the other, so just be aware of that. Learning objectives for the course are described on this slide. When you complete Chem 234, you will be able to perform fundamental experimental techniques in organic chemistry. Some examples of these include being able to distill liquid mixtures, recrystallizing solids, operating chemical instruments, separating mixtures using chromatography, and many, many others. You'll also collect and interpret experimental data, you'll record your results, and you'll submit reports on your results. You'll learn to solve chemical problems and describe the structure and behavior of molecules. These kinds of problems will help with the lecture course, and there's strong overlap between the lab and the lecture, Chem 235. Finally, you're going to be able to use organic chemistry to explain certain aspects of the natural world. For example, why don't oil and water mix? You'll understand that at the end of the course. What are the pigments present in spinach leaves, for example? How can you take an unknown drug molecule and identify it? And there's many, many others, but just having a better understanding of the natural world. The cool thing about organic chemistry is it really explains a lot about how the world works. And hopefully at the end of the course, you'll be able to appreciate that and describe it to someone else. The format of the course is described on this page. We're going to be using a modified tutorial format with attendance modulation. Now, those terms essentially mean that some of the course meetings are going to be face-to-face while others are online. Every other week, the course is going to meet in person to physically carry out an experiment in the lab, so you'll actually show up to a lab where you actually physically do a lab in the laboratory, and online experiments and activities will be planned for the weeks when we aren't meeting in person. The course syllabus will have a detailed schedule describing the dates of the in-person experiments and the online experiments. Next, we're going to talk about the people teaching the course. So first of all, there's the course coordinator. That's me, Brant Kedrowski. I'm going to set the curriculum, create the syllabus, organize the lab schedule. I'm going to maintain the course Canvas site, an online homework site. I will post videos and other content for the entire class. Then there are lab instructors, so that includes me and Dr. George Vader-Olsen. These instructors will work with you in your in-person course sessions. They'll grade your assignments, answer your questions, and Dr. Vader-Olsen and I will work closely together to be sure the lab experience is consistent from section to section. It shouldn't matter who's teaching your section of the course, you should get the same experience either way. Here we're going to describe some attendance policies that are associated with the modified tutorial format of the course. Attendance at in-person course meetings is required, with some exceptions. This is different than the HighFlex course format that you might be using in one of your other courses. In the HighFlex model, you can choose which days you attend courses in person, and anytime you want, you can switch back and forth between online and in-person versions of the course. In the lab this semester, in the modified tutorial format, you're expected to come to all in-person class meetings, except under the following circumstances. Here are some exceptions. If you are in a high-risk health group and don't feel safe attending in-person labs, you can request to take the course 100% online by September 4th. If you decide later that you need to switch to taking the course 100% online sometime during the semester or after that September 4th date, this request then needs to go through the Dean of Students' office for approval. If you happen to get sick or are quarantined, you'll continue to take the course online until you can safely return to in-person classes. Just email me at the email address shown here to coordinate this. And finally, and this is very important, please don't come to lab if you're sick. You can contact me or your instructor by email. We'll find an alternative method for you to take that particular lab online, but please stay home if you're sick. We have some special safety precautions that we're going to be taking this semester as a result of the COVID-19 pandemic. First of all, I want to say that protecting the health and safety of students and instructors is our top priority in this course. Nothing's more important than that. And we've taken several precautions to help make the lab as safe a place as possible. Here's what we're going to be doing. First of all, we have personal protective equipment, PPE, that we'll be using. That'll include masks, goggles, and gloves. We're going to be working in a lab with strong ventilation from the fume hoods, and this will help reduce exposure to respiratory droplets. So the lab is actually one of the safer places to be indoors on campus. Then we're also going to be practicing some physical distancing policies, and those are going to limit close contact with classmates, which should also help prevent the spread of the virus. Some of the specific physical distancing policies are listed on this slide. We're going to have 6 feet of space between students provided while you're in the lab. And the way we're going to do this is that all 18 students are going to meet during the same weeks for in-person labs. So on a given week, if it's an in-person lab week, everyone will show up, but we'll be spread out over 2 lab rooms, room HS454 and room HS455 in Halsey Science. And these 2 rooms are connected, so that'll effectively cut the density of the course in half. You're going to be assigned a lab space with a lab computer in one of these 2 rooms that is physically distanced from other students. You'll have your own workspace and your own computer, and that'll be apart from other students. All in-person labs are going to be carried out individually this coming semester, so there's no lab partners that you'll need to get close to converse with or share data with. And common areas around things like balances and instruments will have a taped off space around them, and one person at a time will be in that space using that particular piece of equipment. This is pretty similar to what you're probably already seeing as you go to stores and things, standing in line for checkouts and such, where they've got spaces cordoned off for one person at a time to use a particular space. Finally, we'll be doing office hours virtually, either by email or video meeting. I'm going to be using Collaborate Ultra. Individual lab instructors will have their own preferred ways of doing office hours. Here are some instructions for how to navigate the course. All content and activities and assignments will be posted through the course Canvas site. Canvas is going to be your go-to place for navigating the course. You can log into Canvas through https://uwsh.instructure.com. The course syllabus and lab manual will be posted in Canvas and will be available for downloading and printing if you'd like a hard copy. You're welcome to print and bring a hard copy of the lab manual, but you don't necessarily have to because you'll have access to it virtually on a computer that's in the lab and networked. Having a hard copy is up to you. All course activities are going to be organized around experiments that we'll be carrying out each week, and these experiments will either be in person or virtually, depending on the week. Every other week it'll be an in-person experiment, and then on alternating weeks there'll be virtual online experiments. Each experiment is going to have its own module on the Canvas course site, and you just need to follow through the readings, videos, and assignments that are posted in each module for that particular experiment to work your way through the course. Getting help. Contact the course coordinator, that's me, Brant Kudrowski, if you're having any difficulties with technology that are affecting your ability to succeed in the course. This could be things like computer hardware issues or software problems, problems with internet access or limitations in data, access to Canvas or use of the Canvas site, access to saplinglearning.com or any of the functions in saplinglearning.com. If you have any technology issues, reach out to me and I will help find a solution for you. If you have problems in the course, questions about course policies, content, or assignments, contact your lab instructor or me, the course coordinator. Our email addresses are shown here, mine, Dr. Vader Olson's, and Michael Foley's. Tutoring resources are also available through the Center for Academic Resources, or CAR. You can visit their website, shown here, to request a tutor for the course if you need one. We also have a Dean of Students office. They will provide assistance for students with personal and emergency situations. They also coordinate accommodations for students with disabilities. You can visit their website at the link shown here, or for additional information, you can call their number, which is also listed. We have a counseling center that is free and confidential for students to use. If you would like to use the counseling center, you can visit their website, which is shown here, or you can call them for additional information. The University Police can also be a resource if you have a non-emergency crime you need to report. Bias incidents can also be reported to University Police at the website shown here. I've included a statement on inclusivity and respect for diversity in the syllabus, and I'm going to read it here. I believe that the scientific community is strengthened by the diversity of its members in areas including race, ethnicity, nationality, religion, gender identity, sexuality, and socioeconomic class. I'm especially committed to increasing the participation and success of those populations that are underrepresented in chemistry or historically marginalized in higher education. My goal is to provide a learning environment that promotes inclusivity and is respectful of diversity. If you experience any problems with inclusivity or respect for diversity from anywhere in our learning community, please let me know. Brant Kudrowski at my email address shown here. I will work to correct the problem. And I really do mean this. I've worked in the McNair program over several summers here at the University of Wisconsin Oshkosh, mentoring students from underrepresented groups, and it's been a very rewarding experience. So I really do believe in this and feel strongly that everyone should be included. This section deals with academic honesty, integrity, and fairness. Students are responsible for the honest completion and representation of their work, for the appropriate citation of sources, and for respect of others' academic endeavors. These responsibilities are described in UW System Administrative Code Section 14.03. Students who violate these standards will be confronted and must accept the consequences of their actions as outlined in UW System Regulations Section 14-04. Some examples of academic misconduct or areas where students could get into trouble are, for example, copying the answers of other students or allowing another student to copy their answers for things like quizzes, homework, notebook, and lab assignments, and those sorts of things. I encourage students to work together in the course to help each other and to learn from each other, but you just need to make sure that everybody is contributing and learning. When people get into trouble, it's usually that they take shortcuts and fail to meet the requirements listed above. So that brings us to the end of this introduction video. In subsequent videos, we'll be talking more about course content and the nuts and bolts of grading and assignments and that sort of thing. But I just want to take this opportunity to again thank you for watching and welcoming you to the course, and I look forward to seeing you in the coming semester. Stay tuned to Canvas for more course videos and consider subscribing to my YouTube channel.